studying trigonometry. Okay, so kind of like I showed you last time, we drew a unit circle. Okay, means a circle whose radius is 1, centered at the origin. Okay, what I'm going to be interested in now, okay, is determining some key points on that circle. Okay, so the important points are this one. I'm going to tell you what they are in a second. Okay, these ones here that I'm putting down in pink. These points are very important. They're key points on the circle. And obviously, these ones are obvious. The coordinates of these ones are easy. Could you tell me what this one is? What's that point?
1.
1, 0. It's a coordinate, right? 1, 0. This one is
0, 1.
0, 1.
Minus 1, 0.
Minus 1, 0, and 0, minus 1. Okay, good. Okay. Now, obviously, these coordinates depend on if from the x-axis I open an angle, say I open the angle, and when I reach a certain angle, every different angle corresponds to a different point on the circle. Okay, so I'll be interested in some key angles, and the angles that I'm interested in are 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. Okay, so I'm going to write them. I'm going to write the angles that are interesting for me. Okay, and obviously there is 0 degrees. Here there is 30 degrees, 45, 60, 90 degrees. Then let's do the whole circle. So 120 degrees, 135 degrees, 150, 180, 210, 225, 240, 270, 300, 315, 330, and of course 360. Okay, so these are the angles for which I want to find the coordinates. Okay, so again, when I'm talking about an angle of, let's say, 120 here, what does that mean? It means that if I connect a radius from the origin to that point, right, the angle here, this angle, is 120 degrees. Okay, so from the x-axis, from the positive side of the x-axis, I'm opening 120 degrees. Okay, good. And so, any questions so far? Okay. First thing is that now we're grown-ups, right? We're not in high school anymore, so we're not going to measure angles in degrees anymore. We're going to measure them in radians. And so I want to show you how to measure angle in radians, or at least how to convert, okay, from degrees to radians. Okay, so I'm sure some of you have seen this, but like I said, it's always good to hear it again. Okay, so measuring, let me just move up a bit. Angles, so in radians. Okay, so how do we convert? Okay, so the conversion is as follows. The angle in degrees divided by 180 is the same thing as the angle in radians divided by pi. Okay, this is how you convert from degrees to radians, and of course from radians to degrees. Okay, let's do an example or two examples. So, example, let's say 60 degrees is equal to how many radians? Okay, that's one example. Let's do another one. Another example here. Let's say 240 degrees is equal to how many radians? Okay, good question. Okay, so I'm just going to apply this rule here. Okay, and of course, this is just technically how to find it. Later, I'm going to explain to you what this really means. Okay, so for now, 60 degrees. So 60 over 180 is equal to the angle in radians, which is what I'm looking for, over pi. And then I'm going to isolate x by sending the pi up here. So x is equal to pi times 60 divided by 180. And if you simplify, you reduce the fraction, you'll get pi over 3. Good? Are there any questions on this? Okay. Let's do 240. You want to try it? You want to try 240? Take 2 seconds and try it. Okay, so 240 over 180 equals x over pi, which means if you isolate pi, you'll get pi times 240 over 180. You could simplify the fraction, you will get, should get 4 times pi divided by 3. Okay, good. All right, so let's go back to our circle upstairs, right? I mean upstairs, right up here. And let's right next to each of the angles in degrees, let's write the corresponding angles in radians. Okay, so 60 degrees we just found below, it was pi over 3. Okay, 0 of course will be 0. Okay, so 240 we just found was 4 pi over 3. Okay, and I'm going to fill in the rest. Okay, so a very good exercise that you should do. Okay, at time, and if you don't know this, is to try to evaluate each of these angles in radians. Okay, so I'll do them for you. So 30 degrees is pi over 6, 45 pi over 4, 90 degrees is pi over 2, of course, because pi is like 180, so 180 over 2 is 90. 120 is 2 pi over 3. 135 is 3 pi over 4. 150, 5 pi over 6. 180 is just pi. 210 is 7 pi over 6. 225 is 5 pi over 4. 240 we just did. 270, 3 pi over 2. 300 is 5 pi over 3. 315 is 7 pi over 4. 330 is 11 pi over 6. And 360, of course, is 2 pi. Okay, 2 pi, 2 times 180, of course, is 360, pi being 180. Any questions until here? Okay, good. Okay, so at this point, I'm going to do the exercise of finding the coordinates of each of these points, okay, for each of these angles. So to each angle corresponds a point on the circle, and that's what I'm looking for. Okay, so let's start with the easy ones. Okay, I'm going to put them right away. So, of course, this one here, that's the easiest. This one is 0. This one is also easy. 0, 1. This is also good. -1 is 0, and this is 0, -1. Any questions? Okay. So now let's work a bit to find these three here, 30, 45, 60. Okay. Why am I only concerned about these three? Because if I get 30, well, the y coordinate is pretty much the same as 150. And the x coordinate is exact, right? Reciprocal, negative. Okay, if this is positive something, this is negative. Are you with me? Or I lost you? Anybody would like me to repeat?
That's okay.
You okay?
Yeah, it's good.
Okay, let's go. So this is what I'm going to do now. So I'm interested in the 30 degrees for now. So pi over 6. Okay, so let's get used to radians now. So I'm interested with pi over 6. So I'm going to draw a triangle here. Okay, a right triangle. Okay, and of course the coordinates x, y, well, this is 1. This here is x, and this here is y. Okay, and that will give me the coordinates here, x, y. This is 90 degrees. Right? We're good with this? Questions? Okay. And this, of course, is the angle theta, which in our case, the angle is pi over 6, or 30 degrees. Any questions? Okay. So now I'm going to go with the other paper that I prepared before. Right here. Okay, so I'm going to put it like this. You can see better. Okay. All right, so you could see this triangle here. This triangle here, I'm going to replicate here, and I'm going to start working inside this triangle and see if there's a way for me to find what x and y are, if this is given that this is 30 degrees. Okay, so let's go. Theta is pi over 6. Okay, so 30 degrees. Okay, so let me draw the triangle. So something like this. Okay, so I'm just redrawing this triangle that I have there, exactly as close as I can to drawing. And I'm going to write down the values that I know. Okay, the measurements I know. So I know that this is 90 degrees. This I know. Okay, and so I know that the angle here is 30 degrees. I know that this measures 1. I know that this measures x, and this measures y. This I know. That's all I know. Right? Question? Okay. So what I'm going to do now is I'm going to draw the exact same triangle right under it. I'm going to recopy this triangle and replicate it right below. So here, same exact thing. Okay. this is still 30 degrees. This is still 1. Okay, and this is still 90 degrees. And this is also 1. You guys okay? Okay. So what else can I conclude here? Look at the top triangle. 30, 90. How much is this angle here? How much is this angle?
It's 60.
Yeah, right? 30, 90, 60, because the sum of the angles on the triangle have to be 180. And so this is also 60. You guys okay? Well, I could see that this big triangle now has 60, 60, 60. What kind of triangle is this?
Equilateral triangle.
Equilateral triangle. So this is an equilateral triangle. Therefore, all sides are congruent, right? They all measure the same. So they're all equal to 1. So 2y, right? This side here, which is 2y, has to equal 1 as well. And therefore, y has to equal to 1/2. Oh, I just found y. Is this okay? This is, I found y. How am I going to find x? What do we use to find x?
We use sine.
No, I don't know. I don't know what sine means.
Oh,
Okay, for now, I'm just using geometry. What do I use?
Pythagorean theorem.
Very good. Okay, so we use Pythagoras theorem. Okay, and therefore, so we have x squared plus y squared, so 1/2 squared equals 1 squared, which means that x squared is 1 minus 1/4. x2 is 3/4. And so x is, I do the square root, I get √3/2. There you go, I found the x. I found my point. You guys okay with this logic? Okay, so this is very good for us because now I could go back to my circle. Okay, and I just found the coordinates here. I just found that x is square root of 3/2 and y equals 1/2. That's very good news. Get it? And given this point, I could find this one here now. Tell me how much this one for 150, what's it going to be?
minus square root of 3 over 2.
Minus root 2 over 2 and
1/2.
1/2. You get it? Okay, so now I have this one. I could actually find this one also. And if I have this one, I'll be able to find this one as well. Okay, so let me find, what is this one here? 210 would be minus root 3 over 2 and minus 1/2. They're both minus because I'm in the third quadrant. And here I will have root 3 over 2 and minus 1/2. There you go. I just found 4 points, one shot. Any questions? Good. Let's go to the pi over 3 now. Okay, so let's go to 60 degrees. So now I'm interested in the coordinates of this point. So straight down here, 90 degrees, theta, again, x, y, and 1. Are you with me? Am I going too fast? You're fine? Okay. So now again, I will redraw this triangle separately here and see if I could find what x and y are with same type of logic as what I did here. Okay? So let's go now. Theta equals pi over 3. Let's go. I'm going to redraw this triangle here. Okay, so this is a triangle I'm drawing. Again, let's put the values that I know. So this now is x, this is y, this is 60 degrees, and this is 1. And this is 90 degrees. Okay, so let's do the same process as before. I will add the same triangle now to the right. Same triangle means that this is 60 as well. And this is still 1. And this is also x. Questions? Okay, so this and this are each worth 30. And again, this is an equilateral triangle. Okay, so let me write this again. So this is an equilateral triangle again. And therefore, 2x has to also equal to 1. Which means that x is equal to 1/2. Question? Okay, and then to find y, we're again going to use Pythagoras theorem. So 1/2 squared plus y squared equals 1 squared. Which means that y squared is 1 minus 1/4, which means that y squared is equal to 3/4, which means that y is, again, √3/2. Any questions? Okay, let's go back to our circle. Okay, I'll go back to my circle right here, and I'm going to place the coordinate that I just discovered. So we said that the x was 1/2, and the y was √3/2. Okay, and then again, let's find all the points that we could find right away by symmetry. Okay. Okay, are you okay if I fill them right away? I think you understood, right? So this will be now -1/2 √2. Here would be negative, and here it would be positive, so 1/2 and -√3/2. There you go. I don't need this triangle anymore. I got my coordinates. Any questions? All right, let's do the last angle, which is 45 degrees now. Okay. So right here, straight down, 45 degrees, theta, this is again 1, this is x, and this is y. Talking about this triangle now. So this one is easier, you'll see. Okay, questions? Am I going too fast? Okay. So let me draw this triangle, let me isolate it. So 90 degrees. (45 degrees), 1, x, and y. Okay, I just redrew the triangle. Okay, how much is this angle here?
$45.
Perfect. So what kind of triangle is this? This is a what?
Isosceles.
Well, it's a right triangle, that's for sure. But it's also isosceles, right? How do I write isosceles? It's SC, I guess. I don't know. I forgot. I think it's SC. SC, like this. A right isosceles triangle, right? Because it's right because it's 90 degrees, and isosceles because there's two angles that are the same. So therefore, two sides must be the same, and so which means that y has to equal to x as well. Okay, these sides are the same. We're good? Okay, so I could use Pythagoras again. We use Pythagoras theorem. Okay, and we get x2 plus x2, right? They're both the same, equals 1 squared, which means that 2x2 equals 1, x2 equals 1/2, and so x is equal to y, the same as 1 over square root of 2, or if you prefer, root 2 over 2. They're both, x and y are the same. Okay, and now we could fill in everything in our circle now. Okay, so let me just go back to my circle. So root 2 over 2, root 2 over 2, same. And then again, let's take care of all the corresponding points, which I could find right away. Okay, so this will be negative positive. So negative root 2 over 2, root 2 over 2. This one will be negative negative. And this one will be positive negative. So root 2 over 2 and negative root 2 over 2. This triangle anymore. Any questions? Okay, so this is what we call the unit circle. I showed it to you last class. I told you that what's the name of it. So this is called the unit circle. Okay, because it has a radius of 1. And these are all the very important points that you need to know. Okay, so should you learn them by heart? I mean, not intentionally, but you're going to see them so much that even if you don't want to, you'll know them by heart. Okay, any questions? Okay. Okay, so let me just one quick note on what does it mean radians. Okay, so what do these values mean? So pi over 6, pi over 4, pi over 3, these ones. Okay, so they're a way to measure an angle. Okay, or what it actually means, it's the length of the arc from here to here. So if I open 30 degrees, okay, if I open 30 degrees in the unit circle, the length of this little curve here, right? It's like if this was a pizza slice, then the crust, okay, the length of the crust is exactly pi divided by 6. Okay, if I go 45 degrees, well, this length is pi divided by 4. So if you want pi, so shift pi divided by 4. So it's about 0.785. Okay, this is what this measures. Okay, and it makes sense because look, if you do the whole turn, the whole circumference, okay, so the circumference of a circle is 2 pi radius, right? 2 pi times radius, but the radius is 1. So it's just 2 pi. That's why it's 2 pi. Okay, so 2 pi times radius, 2 pi times 1. Okay, or 2 pi radians. Okay, radians, we call this radians. It looks pretty much like radius. That's why it's 2 pi radians. It's the length of the arc in the circle was a radius of 1. Okay, so it's 2 pi times the radius, basically, which is 1. Makes sense? Okay, and obviously, as you see, pi is half of 2 pi. Half of the whole circle, you get pi. And that's the way to measure. It corresponds to 180 degrees. That's all it is, okay? In Cal 2, in this course, especially in Cal 2, you're only going to deal with radians, okay? Even here, maybe a bit of angles, but next course, only radians. Okay, so you have to get used to this. Okay, that's it for today.